Okay, go ahead. I've started recording.
So, hello everybody, good night and good morning all over the world. Welcome to our presentation about circular economy, agriculture and biomass. We are two professors here giving the talk. I am Berger from UP, Universidad Panamericana in Aguascalientes, Mexico. And here on my side is the engineer Sergio Garcia, and maybe he wants to introduce himself.
All right. Hello, everybody. It's a pleasure to give this talk. So, yes, I'm Sergio. I'm industrial engineer, and as part of my background, I also studied permaculture, and also I'm working on my thesis. It's a master degree in natural resource management. Um, So the last 8 years, I've been working on different areas regarding sustainability, and my experiences and trainings has been in different countries, fortunately: Israel, Palestine, Jordan, the States, Peru, Portugal, and Spain. And now I'm here also part of the university. I'm the responsible for giving the lecture about sustainability. And yeah, that's what we are gonna talk about, how sustainability is addressing some problems that is or they are needed in agriculture. So this is pretty much related also with circular economy, as we will see later on. So that's it. Thank you.
Thank you very much, Sergio. So I'm a professor here at UP for more than 3 years now, and I developed some projects in biomass and circular economy, and I'm really happy to be able to tell you something about this. So so first of all, I will introduce you to our university in Aguascalientes and Universidad Panamericana, and the other two campus in Mexico City and Guadalajara. Then I will talk a little about circular economy and biomass, and afterwards Sergio will give you a talk about sustainable agriculture. So here you have a map of Mexico, and this blue dot in the middle, this is the state of Aguascalientes with the capital Aguascalientes inside. You have some beautiful pictures of our city. We have about 1 million inhabitants here. So these are some pictures from our campus. So this is the campus in Mexico City. It's a nice hacienda, and this is from our campus. We of course we have a project with solar panels as well, because of all the sun we have in our beautiful city. So here you have the three campus: Aguascalientes, Guadalajara, and Mexico City. And the programs, the IME program will start here at our campus in Aguascalientes. Our total student population is about 15,000 students. We have around 1,600 professors at all the three campi, with nearly 500 of them have PhD, more than 1,000 masters, and 130 specialists. And our number of researchers is growing every year. We have 36 undergraduate programs, 7 postgraduate degrees programs, 8 PhD programs, and 8 different faculties in the three campi. At our campus, Aguascalientes, we have 4 faculties. This is international business, engineering, and law, and pedagogy. And we have 12 bachelors, 8 masters, and 1 PhD program. So as the Professor Sergio and I, we are here at the Faculty of Engineering, where we have 600 students and more than 30 professors working here with us. Our research interest is in robotics and electronics, artificial intelligence and energy technologies, which includes now, of course, circular economy projects. We have more than 100 international partners all over the world. And maybe Mexico joined, will join the IMED program, and we will start in the beginning of next year. So every student from all the world is really welcome, and we are really happy to welcome them here at our campus. So Mexico is, as many other places in the world, has a lot of challenges. So we suffer from water scarcity, eutrophication, siltification of soils, poor harvest, waste in landfills, global warming, and so on. And so nevertheless, we have all these challenges, what we can call problems as well. 1/3 of all the food in the world is wasted. So this means as well that less land is available and less food is available. And of course, this is a lot of waste in money for each person and for the community itself. And there is one solution in it. So it's, of course, not the linear economy, it's our circular economy. Already had a lot of talks about it. So it's about enhanced flows of goods and services. We try to design out waste and pollution and keep products and materials in use and regenerate natural systems. There are many schools in circular economy. So for more than 30 years now, for example, Walter Stahel from Switzerland or Jenny Invenius, who's talking about a lot of biomimicry. I really want to encourage you to learn a little bit more about them. All of them are kind of connected, but anyway, they're really interesting, each of themselves. But now I want to start definitely to talk about the circular economy and biomass and how it is connected. So here's a graph you already saw from the other professors earlier. And what we have here is more the technical industrial part. And on the right-hand side is the blue one. So sorry, my mouse doesn't work really well. And here the green part, so this is actually bioeconomy. And what we have here, so this is from the International Energy Agency. So it talks about bioenergy and biocascading. And so I will talk a little bit about that now. So there are 5 EU priority areas for circular economy. And I will give more focus on the biomass and bio-based product part and plastics and biodegradable plastics, actually. So when you talk about bioenergy is energy derived from biomass. And biomass is material which is directly or indirectly produced by photosynthesis, so it means by the sun, and it is utilized as a feedstock in the manufacture of fuels like diesel or ethanol, and petrochemical and other energies. So, but it includes as well organic waste from forestry and agriculture, of course, and municipal solid waste. Biomass is any living organism, plant and animal. And so there's 174,000 multiplied by 10 above 12 watts of light power that comes to the earth. And just 0.023% of it is used from the plants. And of course, fossil fuels represent stored biomass energy. So bioenergy can play important and constructive roles in achieving the UN Sustainable Development goals and implementing the Paris Agreement on climate change. This is, everybody knows it. It's from 12th of December in 2015, the COP 2021, and of course everybody, well, some countries got out of it, but these are really important goals we have to reach, and bioenergy is really helps to do so. There are several options for sustainable bioenergy expansion, including sustainable intensification and landscape planning. Professor Sergio knows a lot about it. We'll talk about this later on. Using waste and organic residues, this is what I will talk about. And restoring degraded and marginal lands, this is as well Professor Sergio's part. Bioenergy is part of a larger bioeconomy, and bioeconomy encompasses the production of renewable and biological resources and the conversion into food, feed, and bio-based products and bioenergy via innovative and efficient technologies. So for bioeconomy includes renewable energy, renewable products, and uses it or tries to integrate it into cascading. We will talk about this. So bioeconomy is circular by nature. So this is, of course, it plays a big role in circular economy. Bioeconomy regenerates CO2 and uses renewable raw materials to make greener everyday products. Bio-based products and materials have the benefit of achieving a more balanced carbon cycle in comparison to fossil alternatives, of course. And circular economy is complementary to the renewable character of the bioeconomy and must facilitate the recycling of carbon after efficient uses. And here I can give you a really nice example about a biochar product we are using. So bioeconomy supplies renewable energy and supplies material that can be well cascaded, like wood and fibers, and supplies feedstock for plastics, or biodegradable plastics, for example. So, of course, you cannot have your cake and eat it, and this is what biorefineries talks about. It's the task 42 from the International Energy Agency, and what it says, so when you have biomass cascading, it says you have you first try to get high value product. Of course, you will have less of it, and then when you cannot use it anymore, you try to have another product with a little bit less value, but you will have more of it. So when we have like a pharma product or cosmetic product, it's a high value, and then you can maybe afterwards you can use it as food or feed, and in the end you will have really have the possibility to have a low value product, but a lot of it, and you can always use it as energy or heat. So this is what cascading is about. It. So you can like imagine it as a river going down, and you will never throw it away. You will just use it always. Biorefining. So this is the task 42 from the International Energy Agency. It says basically the same, that you have a product and you give it a treatment and separate all the important ingredients you still can use, like proteins or lignin or oils, fibers, and sugars, and then you make out of it what you really need, like food or energy or other chemicals. So this is just an example of all the bioproducts you can make after biocascading in the bioeconomy. And I want to give you some examples of circular economy and bio-based products we have at UP Aguascalientes, Mexico. So one is our biochar project, and the other is our project on a biodegradable plastic made of which is bio-based as well. So we start with biochar. So what is biochar? Because it looks just like charcoal. Maybe you can say that it's like a high-class charcoal, and it has a lot of history, so more than thousands of years. It was used as terra preta in it's known from the Amazonas region in Brazil. So it's really, so this is earth or soil mixed up with charcoal or with biochar. And people living there in the Amazonas thousands of years ago, they just got to know they will have they will have a really much higher harvest using terra preta instead of nutrition well, instead of an oxy soil that's poor in nutrition. So here's the region from the Amazonas region where they could find charcoal areas. It was really common to use and kind of forgotten. So what is biochar? It's a carbonic material. It actually has more than 50% of carbon, so it's a really important for sea storage, and of course this reduces like the CO2 in the atmosphere. Has functional groups that are really important for soil fertility, and one big trick or a nice property of biochar is its porosity. And this is really important for the water holding capacity as well. So it has its physical and chemical properties. It has a really high surface that's close to activated carbon, has a high water holding capacity, what's really important for sites like Mexico or Morocco, where you have deserts or half deserts, and you have an increased cation exchange capacity, what is important in soil remediation. The biological properties, it's beneficial for microbes and fungi, and has increased nitrogen, phosphorus, and potassium uptake. And so the plant can use the nutrition in a really better way. So all the pores in the biochar are like 5-star hotels for the microorganism, and so they make available all the nutrients for the plants. So this is one really important property from biochar. So its benefits are for the climate, so sea storage or CO2 capture, important for energy, better for soil enhancement or soil remediation, and of course in waste management, because what you use in biochar is waste wood or untapped wood that has no need anymore. Instead of throwing it away or putting it into a landfill, you just turn it into a high value product what is biochar. So the applications and advantages is for soil and water. It can be used in agriculture and livestock farming. So you can give it as a food supplement to animals. So you need your animals will feel a lot of better. And of course, in the end, this is all about money and economy. So the applications is for soil remediation, soil amendment. It can be used for filters, any kind of filters for water or in the kitchen. It's a food supplement and decreases bad smells as well. And it's a sea storage. So this project I'm doing with Roberto Rico Martinez from another university in Aguascalientes, and our PhD student Felix Flesch, who's working at IFAS as well. So what we did, so we wanted to know how much untapped wood we find in Aguascalientes, and if this wood, so we thought this wood will be, we can turn it into biochar that complies to the requirements of the European Biochar Certificate, and afterwards, this is something we still have to do. We will find its monetary value. So how much money you can save in using it, or how much you would lose if you don't use biochar. So we took our primary material from 3 different sites in the state of Aguascalientes. That's a municipal landfill and the composting and forest in the north of the country. So here you have a photo, a picture from the landfill from Aguascalientes, and this is from our municipal composting site. And this is how it looks like. So primary material, so just like wood and in different size, untapped wood, nobody needs it anymore, and we turn it into biochar using a Contiki kiln. It's an open curtain kiln made well, designed by Hans-Peter Schmidt from the Ithaca Institute. And so it's a performance of 50 kilograms of biochar in 6 hours. So the efficiency is about, so you put 3 parts of wood in and become 1 part of biochar out. So this is like the Contiki in action. So it looks like it's burning, but actually it's a pyrolysis process. So in the beginning it's burning, but it's basically pyrolysis where no oxygen enters. This means the carbon, the C stays inside the wood instead of going out or compound with the oxygen from the atmosphere, and instead of going out in form of CO2. So the carbon stays inside the wood, so it says it's a carbon storage. So we had to make a compost as well in order to enrich our biochar, because before introducing it to the soil, it has to be enriched with nitrogen, with nutrients, nitrogen, phosphor, and potassium. So this is how it looks like. We have to quench it because this opens the pore size. And here what was really important for us to fulfill the criteria of the European Biochar certificate. So certain chemicals have to be low, like PAH or PCB, and other toxic ingredients we cannot introduce to the soil, and therefore we made some chemical analysis. And so afterwards we will define the monetary values of the biochar application along agrarian value chain here in Aguascalientes, but of course you can do it for any site in the world. The other project we have is our bioplastic. So what we want to do, we will produce biodegradable plastics based on orange peels. So just to say some bioplastics, so it can be biodegradable plastic, or it can be a plastic made of bioproducts. But what's really important in the end is that it's biodegradable. So you can, so bioplastic is not bioplastic. So ours is bio-based and biodegradable. The idea behind it, we have too much untapped orange peel, and we have too much untapped plastic. So the Mexico, for example, here it's a really important producer of orange juice, and this is why the waste of orange peels is so high. And as well the anti-plastic. So we are thinking that in 2015 we will have more plastic than fish in our oceans. And so this is too much, because and now nearly 300 million tons of plastic are produced every year, and 50% of it are just thrown away, just end up in the fields, in the lands, or in the oceans. And more than 8 million tons of plastics are dumped into our oceans every year. And as you know, they're becoming smaller and smaller, and the real problem is the micro, or later on the nanoplastics, because plastic just gets smaller and smaller, but it's never really degraded. So the justification for this project, for this biodegradable project, is well, plastic is cheap and incredible versatile, and we really got used to it, to use it, to have it. But of course, we caused a lot of environmental problems with it. So with an average volume of more than 4 million tons, Mexico is the fifth largest producer of orange, and about half of that is orange peel waste. So 2 million tons of orange peel every year. The amount of the world industrial waste of citrus is estimated about 15 multiplied by 10 per 6 tons. So it's a really big amount. And actually, there's no real use for orange peel. It's difficult to use it in a compost because of its essential oils. It's difficult in a biodigester. It has so much acids, and animals don't like it neither because it has a bitter taste actually. And so we have a global biomass supply of 11.4 gigatons a year. And when we estimate that we have an efficiency of 50%, so out of 2 kilograms of biomass, we can make 1 kilogram out of plastic. So it would be 6% we would just need 6% of all the biomass in order to produce bioplastics. So there's a lot of biomass available to do so. So our project is to produce a bioplastic based on orange peel and verify its usefulness, change our disposables at our cafeteria first, at our UP cafeteria with our bioplastics, and afterwards kind of automate the production and organize the sale with our industrial engineers. So this is how our first results look like. Of course, I cannot tell you the receipt we're still working on. Future ideas are like furniture or nice cups where our students from design can work in. So it's always good to have a deeper look. And I have a recommendation for further reading for you. This is a really nice paper on the effect of bioenergy expansion, and as well a nice, so this doesn't work. Nice talk from Janine Benyes about bioenergy. So I really recommend this for you. And now my colleague, Sergio Garcia, will go on with sustainable agriculture.
Okay, so sustainable agriculture. This is a statement made by the UN, the FAO, the Food and Agriculture Organization, which is part of the UN, as you might know, and says that a common vision for sustainable food and agriculture must equally address social, economic, and environmental dimensions to ensure sustainability. So this is pretty much not only related, but in terms of permaculture, this conception is also looking to mimic what nature does, basically, in order to reuse, or in this case to recycle as well, the scrap or the trash or basically the leftovers of any production, right? So in this sense, what we are trying to do for sustainable food and agriculture is mimicking again what nature does, because if we look at it, we see that in nature there is no waste at all, because those waste are used for other purposes or other processes within the nature. So this is basically the concept that was mentioned, if I'm not wrong, but in the first presentation from the professor Naus. He said that where the difference now within circular economy and linear economy is that the output and the trash is used for other purposes and creating these new models for businesses and things like that. So then there are some principles to collectively guide the process of transition in terms of sustainable agriculture, because nowadays what we are doing in the countryside, in what we can say it is the global south, is not pretty much sustainable at all, and we have seen already the consequences and side effects of these non-sustainable ways to produce food or to treat basically the natural resources. Therefore, the UN, together with more organizations, not only from the academic world, but also from grassroots movements and also research institutes, are working together in order to integrate both perspectives. So these principles basically are looking for improving efficiency in the use of the resources. One statement that is pretty, I would say, tough says that agriculture that fails to protect and improve rural livelihoods and social well-being is unsustainable. And as you might know as well, 30% more or less of the inhabitants all over the world are farmers who are producing the food for the rest of the world. So we have, and therefore, or not therefore, sorry, unfortunately, these farmers, in most of the cases, they don't have this improving of livelihoods. They are still living in a lot of scarcity. They are living, they are having this famine, Bruna, sorry. So this is why it's so important to start moving towards this new trend in terms of sustainability. The next slide is about within sustainability, there has been different approaches. So one of those is the socio-ecological systems, which just to give you a better framework and also to remember that something that is sustainable has to address four dimensions, which are political one, environmental one, economical, and social. So socio-ecological systems are addressing those dimensions, and as you can see here, they are working together with nature and environment. So both social systems are working together with ecological systems in order to make interactions, right? So between these two spheres is basically putting together the whole elements that we need in order to really tackle problems in sustainable agriculture. And just to remark that these socio-ecological systems are not only related to agricultural issues, but also to economical issues and political. So, you know, everything is coming together, and the more complex it is a system, the more resilient it becomes. Therefore, this is the perspective that most of the other disciplines are considering, you know. So as you may see also here in the figure, in the social system, they are including society, economy, culture, and politics. Another strategy which has been a new trend in terms of sustainability is the water, energy, and food nexus. And basically, this is a concept that sees these three elements as being one, but not only separate as nowadays it's like that, not like before, or let's say in some countries they are starting to realize that water, energy, and food has a pretty strong connection. And as I said before, since it's very complex, it is inextricably entwined. Sorry. So just here in the graph, we can see that in this, where probably is too small for you guys. Where is that? Where is that? Okay, sorry. Here in the bottom, you can see the resource base, which is basically the land, water, energy, capital. This is in terms of budget and money that you have, and labor. And this is in order to achieve the goals, which are on top of it. Sorry, but the arrow, this mouse is not working pretty well. So the goals and interest, since we are talking about the nexus about water, energy, and food, those are the main goals, because from those three components, nowadays we are creating new models, not only for businesses, but also to try to restore and to somehow to fix all the damage that we have caused over the years. And the main drivers along a lot of those drivers is population growth, urbanization, cultural and social beliefs and behaviors, climate change. On the other hand, we have the schemes of governance, sectoral policies, and different interests, international and regional trade markets and prices, industrial development, agricultural transformations, and technology and innovation. Those are drivers which are pushing and, let's say, developing and evolving out of this water and energy food nexus.
Octavio. No funciona.
Está muy lento, pero bueno.
Ponlo arriba de primero si quieres.
Ah, sí, creo que sí.
So, the water, energy, and food scale has interconnection and scale, and this goes from local to global interconnection. These scales are going across in this way, vertical, but at the same time they are going horizontal, and they are crossing sectors as water, energy, food, economy, environmental, and others. As you can see, these are also dimensions of sustainability. And why is rounded by this like a circle within science and policy? Because together with society, it is important to work in order to create new policies and new frameworks, but not only to create those, but also to make sure that those are implemented and working on the let's say on the land, in the areas that are needed. because in places, for instance, here in Mexico, it's not about to create moral laws or policies about how to treat water or how to produce energy out of waste and stuff like that. It is also to accomplish and to do and to respect what we already have as a law in this sense. And this applies also in other countries, for sure in Latin America, more or less. We have the same political system in some aspects, the same issues. So science, on the other hand, working together with the politicians, with, let's say, with the government, and science means universities, research centers, NGOs, people who are working together, in this new trend. And the basis try to balance socio-economical factors along with different uses of ecosystem resources. So this is an example. This is a case study of the nexus efficiency of centralized and decentralized models for water management and food production in the region of Alentejo. For those who are from Portugal, you might know that this area, sorry, it's very arid. There is not that much rain, but still you have a lot of these monsonic rains in winter. So there is this project known as Tamara. It is a small community project that has been working on the restoration of the land for the last 15 years, and they have created water retention landscapes using basically or harvesting rainwater, and they are implementing principles of permaculture and scale of permanence in order to, as I said, to restore and reverse the effects of the climate change. And this has been taken as a successful study case, not only in the country, but also in the UN and other countries. So basically, this study case is just to give you an example how you can work this out in order to make the nexus. You can work it out just only using 2 out of the 3 elements. You don't have to work on the 3 of them. So and just very brief, basically the comparison is between the dams, because in the Alentejo area there is this huge system of dams, the Alqueva dam system, which tries to supply water for irrigation in that area. And the concept behind this is, in order to, instead of storaging water in a natural way, they are creating these dams, which are centralized models for this. And I'm not gonna get into the details, but later on you can take a look with more time, and you will see how this systems works. For instance, in a centralized system for water storage, which is this one, sorry, I didn't see it. Well, in this system, basically is coming from, in order to fulfill a dam, to fill a dam, you have to deviate rivers, to displace people, communities, to take trees down. I mean, you have to basically perturbate the area where you want to do this. And on the other hand, when you want to make it in a decentralized way, by creating these water retention landscapes, you are working together with nature. So you are creating small lakes made by humans in order to create this domino effect. By the time everything is gonna change, and this is more sustainable, because this goes from uh, the local perspective, let's say, because you can implement these systems in small areas to bigger scales. And then there is this methodology to make the, I mean, to translate qualitative data into quantitative data, and then to make some graphs to check what is the performance of both systems. So in this case, we made this nexus diagram between water and food in that area. And what we saw is that the explanation of this diagram is framed by four socio-economic characteristics, which is transition country, agriculture-based system, population growth, and it's a dry country, right? So that contributed to identify the main drivers considered for sustainable water management and food security assessment. The double point arrows represents the nexus among the two areas under analysis. In here we can see how water and food are related. For instance, water storage helps to make or to improve the resilience in societies and ecosystems when there is a hazard. Or on the other hand, the land use could support to sustainable use and management on water resources and so on. So the triangle, on the other hand, in the middle, stress out the importance of straight and equal communication, as well as mutual support among the involved parties. So as we saw in other slides, in previous slides, there has to be a common language between, in this case, let's say local farmers, but we can say society in general, the private sector, which could be industries, together with the government. These three elements has to work together in a balanced way in order to really make this happen in a very sustainable way, no? To really make sure that this can make it in that sense. So that's it from our side.